we're going to torch autograd profiler.profile as PRF. Okay. And then we're going to loop through 1,000 iterations and do a whole bunch of math. It's random, unneeded math. We don't need to worry about that. Print. What are we printing here? Key averages tables. Oh, wow. This is a whole bunch of things here. What is going here? What's going here? prf.keyaverages. prf.keyaverages. Dot table. And we're going to say sort by self CPU time total. Sort by equals. Look, why is this? Oh, got it. Okay. So let's play with the profiler for a little bit. I'm gonna see. So we saw what the CPU looks like. Can we do MP? All right, here we go. So that was CPU. So that was 1.7 milliseconds. Hold on. Versus microseconds. I wonder what's going on there. As you can see, something that's very interesting that you would not normally expect. We see here right now. Let me. How do we show this a little bit better? All right, so let's bring this on the screen here. Let's see here. All right, so Python. Let's go profiler. All right, and we'll do the same back over here. We'll take the devices off. All right, here we go. This is something that you would not normally expect to see. Take a look at this really quick. You see here at the top of the screen, we're running an MPS benchmark, and we see the time it takes for division is 8 milliseconds. Now we go down to the bottom, and this is a CPU run, and you see that now we're in microseconds, what is essentially 10 times faster. Look at that. The CPU is faster than the graphics accelerator. Why is that? Well, it turns out there's some latency that is required when it's passing data from the CPU memory, system memory, to the GPU memory. Now, that's going to be slow. That latency is slow. The reason why we're not seeing a speed up here is because we're using very small tensors. Super small tensors. And you're going to get no benefit from an accelerator by running your computations on an accelerator when the tensors are so small. That's what that is. That's what you're seeing there. RAM, it's not enough. You need more for large language models. Okay, so what we saw here was 38 milliseconds on the CPU. Do you guys think it's gonna be faster or slower? All right, so will the large tensors run faster on GPU? Yes or no? Yes or no? Quick little poll here, you guys. Spinning up the poll. Kind of curious to see. Did that poll go through? Yeah, I think the answer is yes also. Because we got to the point where the large tensors are exceeded. It exceeded the CPU. Some of you are saying no. Some of you are saying no. What's a CPU? What are you CPU? What do you mean? What's a CPU? That should be an easy win for the GPU now. Cool Farmer? Yeah, I think you're right? An easy win. All right, you guys, here's the answer. You guys ready? Here's the GPU. It was an easy win. Look at that. The CPU is now at 38 milliseconds. The GPU at 7 milliseconds. The GPU wins by far. Also, if you notice at the division, the profiler can be also label individual subblocks of code. So this is really neat. We can see where our speed up and speed down is in our model. So we can see that the division more expensive than multiplication. What's going on?